So this week I'm going to be proving my colleague Jeremy Blake wrong. He said I couldn't make a 2-minute Tuesday that was actually 2 minutes, so I should rename it to 10-minute Tuesday. So this week we're going to do it in 2 minutes, and I'm going to be telling you why there is so much smoke produced in the corridor in the event of a fire. As all apartment doors have door closers on them, it may seem a bit strange that so much smoke makes its way through into the corridor when a person escapes through their apartment door. Well, the reason for that is down to something that you may have done back in school in science. And I'm going to show you a couple of videos demonstrating via a computational fluid dynamic what happens with that smoke when somebody escapes through the door. And then I'm going to show you a brief experiment and explain the reasoning behind why so much smoke comes out. So here are the videos. What you're looking at here is what's known as a computational fluid dynamic, or CFD model. Now this is used to prove that a smoke control system, typically a mechanical smoke control system, works in the building that it's designed for. So first of all, I'm going to show you what happens when the first escape is made. We can see that a lot of smoke is pouring out into that corridor area. Now let's look at what happens when the second escape is made, because this will help illustrate the point even better. So this time around the fire has grown a lot, and as we can see there's a whole lot more smoke coming through into that corridor, despite the door only being open for a very short period of time. What I'm going to show you now is a very simple experiment which you may have done at school, but it serves to illustrate my point. Following that, I'll then dive into the physics of why it actually happens. So I'm going to take these matches and light a candle that I have right here. I also have this lovely Sertus water bottle, and I've got a balloon on top of it. What I'm going to do is I'm going to hold this bottle over this candle for just a few seconds. See, what you'll notice there is that by warming up the bottom of this bottle for a few seconds, we've expanded the gas inside, and so the balloon stood up. Now, what I'm going to do next is dive into this law of physics of why that actually happens. So the law that I'm talking about is Charles' law. Now, Charles' law states, I'll pull it up so I don't get it wrong, that V1 over T1 equals V2 over T2. And to explain that out, Charles' law is an experimental gas law that describes how gases tend to expand when heated. A modern statement of Charles' law is, when the pressure on the sample of a dry gas is held constant, the Kelvin temperature and the volume will be in direct proportion. Now, putting this into a fire scenario, what we can usually expect in a fire situation is for the room temperature to go from a normal room temperature of 20 degrees Celsius all the way up to 350 degrees Celsius. That's a 1650% increase. When the fire takes hold, we're then going right up to 900 degrees Celsius. I mean, that is a really bad fire. But that is a 4,400% increase. So if Charles' law stands true, that V1 over T1 equals V2 over T2, then the volume of gas in that room is expanding by 4,400%, which is why we get so much smoke pouring through into the corridor. So hopefully that has helped you understand why we get so much smoke in the corridor in the event of a fire, and what Charles' law is all about. Thanks very much for tuning in again this week, and I'll look forward to seeing you next week, and hopefully we manage to prove Jeremy wrong and do this in under 2 minutes. Have a great week, and I'll catch up soon. Bye for now. Okay Jeremy, you win, but I'm not changing the name.